Hello everybody. In today's video I'm going to talk about Azure Password Protection. This is one of the features that was released recently by Microsoft to general availability, and from now on you can simply use that in your environment if you have Azure Active Directory inside your organization. So why would you need to have this feature implemented in your environment? First reason is that because we still see so many users choose their weak passwords, and the issue of weak passwords, selection of weak password is not simply fade away, and this is a big issue for most of the organization. And if you want to completely fade away this problem of selecting weak passwords, you can work with this feature along with having password policies in your environment, and it is going to be quite useful feature for your Active Directory environment. In this video I'm going to talk about how to implement it and how Azure Password Protection will work under the hood. So the very first question is, why do you need Azure Password Protection? First of all, I have to tell that this feature, Azure Password Protection, is a feature that only available to Azure Active Directory, which means that if you don't have Azure Active Directory in your environment, you won't be able to use it. So if you not have this feature, this Azure Active Directory in your environment, this is going to be a good start. It's going to be a good head start for you, because this feature is quite interesting. So why would we need Azure Password Protection when we have password policies in our environment? Password policies are good. They've been working for so many years without any problem. So which means that with password policies, we can force choosing a strong password. By strong password, we mean to force users to have lengthy password, to force users to have complex passwords and things like that, and have password age and password complexity and all the settings that you are aware of. For example, we have two passwords here that are completely compliant with the password policy, which means that they are strong enough, they are lengthy, and they can be considered as a clear example of good password. But password policy is not going to work for every situation, which means that password policies cannot prevent known password. There are so many passwords that they are available to download. Even if you just go to Troy Hunt's website, you can simply download a database of all these known passwords. They are strong, they are lengthy, they are complex, but they're not quite strong. What does it mean? Which means that these password, as you can see, it is quite lengthy. It's like 8 characters, 9 characters, and it's quite complex. But this is just the word password. And it's the password that Microsoft been using during the training courses, during the, you can see basically this password inside the books and things like that. And believe it or not, so many users try to use this password as their password. So this is a very known password, but it is complex. Another example of this is @123 @ABC. It is lengthy, it is complex. It has a symbol, it has letters, it has numbers, but it is very known password. One more example is pass1234. It has capital letter, it has small letters, and it has also number. These are a clear example of known password. They are strong, but they can be easily guessed. So password policy is not going to work against these passwords, which means that even if we have good password policies like a length of 8 characters, quite complex, all the passwords that you can see in the example can be compliant with the password policy. So Azure Password Protection comes into play in such scenarios where we cannot force user to not choose certain passwords. So Azure Password Protection is something that we can use in this scenario in order to ban a specific set of passwords and force users not to choose them. That is exactly what Azure Password Protection is built for. And another example, PA55W.RD. This is quite lengthy password and also complex, but this is just the word password. If we can translate all the words, if we translate all the letters, which is clear that for everybody this is a password. So this is the problem that we have within passwords, and password policy was unable to fix this issue for so many years. But here now, Azure Password Protection can help us to overcome this problem. But how does it work? Azure Password Protection, as we said, is a new feature that works with Azure Active Directory. In order to understand how does it work, let me give you a clear example. Let's say that we have a domain and also we have Azure. Inside our on-premise Active Directory environment, of course, we're going to have domain controllers. And also, we're going to need something called a proxy. This is something that we need in order to implement Azure Password Protection. This server that we said is called proxy server. But the proxy server is not the only thing that we need. Azure Password Protection helps us to implement a list of banned passwords and have them in our Azure Active Directory. And by having that list, nobody can choose a word from that list. So a list is created in Azure Active Directory, and inside that list, we simply insert all the passwords that we see that we can say that they are not good enough, they are not strong enough. So as we can see in the picture, we have pass1234 and PA55W.RD. So when we add these two words into this list, which means that nobody else would be able to choose these words as their password. Fair enough. We add words to the list and nobody will be able to choose them. This list will stay in Azure. So what is the job of the proxy server? Proxy server will work and will act as an intermediary between DC and Azure Active Directory. Which means that this server will be responsible to handle the request from the domain controller to the Azure and that list. So this domain controller will be able to have a copy of that list which is inside Azure Active Directory and will have them stored locally on domain controller. So which means that the domain controller will request to have a copy of that list and will store that copy locally on domain controllers on themselves. And if you want to know where that list will be stored, I have to say that that list will be stored in sysvault folder. This is a shared folder that each domain controller has a copy of it, and it will be used in order to store the group policy and also configuration of Azure Password Protection. And by configuration, I mean the list of banned passwords. So what happens when the client wants to change the password? The request will be directed to the domain controller, and the domain controller will look through the list and see if the password is inside the list or not. And it will decide to whether accept the password or reject the password. The point here to keep in mind is that the proxy server will never have the list itself and will never cache the list itself. So which means that the domain controllers will talk Azure on behalf of the proxy server. It's quite fair enough because most of the time domain controllers do not have access to internet. So if the domain controller wants to have a copy of the list, it needs to contact the Azure. And since there is no connection to the internet for most of the environment from a domain controllers, it will talk to the proxy server, and proxy server will fetch the list for it. And the proxy server, as we said, just give the list to domain controller, and it will never keep a copy for himself, and it will never cache the list. If we modify the list, if we add more words or remove a couple of words from the list will be changed. And as a result, the domain controller will need to have a recent copy of the list. Otherwise, of course, there's going to be some problem with selecting of password. For example, we have a couple of passwords in our list and we just remove them from the list. But if the list does not get replicated to domain controllers, the user won't be able to change the password. So the domain controllers needs to have always a recent copy, an updated copy of the list. And if you ask about the refresh time of this policy configuration of Azure Password Protection, I have to say that every time you start the domain controller, it will request to have a copy of the list. And every hour, the copy will be renewed. So which means that if someone wants to change a password, it will contact the domain controller. The domain controller will look through the list and see if that list is updated enough, if that list is not quite old, and it will look through the list. Otherwise, it will request to have a new list. And the time to leave, or TTL, of this list is 1 hour, which means that if the list is old enough as 1 hour, the DC will request to have an updated list. So it is a key point to understand that all the time the list should be synchronized. Before we move to demo slide, and before moving to implementation, we need to understand how Azure Password Protection works. So Azure Password Protection evaluation algorithm starts with a process called normalization. Within the normalization, there are two sub-processes which they are called uppercase to lowercase and character substitution. So we'll start from the first one. Uppercase to lowercase is a process in which the password and the capital characters of the password is changed to the lowercase version. For example, if you have a password like this and we have two characters P and D which are capital, those two will be changed to lowercase letters, and which means that password will be changed to the second one, which has P and D in small letters. And the second process is called character substitution. Special characters of a password will be changed by their equivalent replacement. For that to happen, Azure Password Protection will run a query against the password, and it will change all the characters, all the unique characters that can be replaced by the letter. Clear example of table is look like this. Like @ will be equivalent to A, $ for S, 0 for O, and things like that. So the result after the uppercase to lowercase change will run through this table. And after that, the characters are changed. And as you can see, @ is changed to A, $ is changed to S, and so on. This is a normalized password. In the second process, this normalized password will be used in order to check if this is in a banned list of Azure or not. The first algorithm is fuzzy matching. The second one is substring matching. And after that, Azure Password Protection will be able to decide if the password is okay or not based on a calculation of scores. So we start from the fuzzy matching. Fuzzy matching is a process in which the Azure Password Protection will decide if the chosen password has an edit range of only one character. Let me give you an example. Look at these three words. What is the difference between these? As you can see, the first word is password. The second word is password with a letter F at the end. And the third one is password without any D, without any F. So it's quite common among all the users. In order to have a new password, they just add a character, or they just simply remove a character in order to have a password. So as we said, password policy will not be able to decide on this one, and we need to have Azure Password Protection to find and ban password like this. This is fuzzy matching, and that's how we decide, and the password will be rejected. The second thing is substring matching. What does it mean? As you can see, the red password is quite strong. It has letters, it has numbers, and it has symbols. Once the password is normalized, it will be changed to something like this. So substring matching will see if within the new password, within the new chosen password, if there is a word or a single word, or there is a substring of that word inside the banned list of Azure. If you have a banned list like this, as we can see there, the word Mati is in custom banned password, the password like that will be rejected because there is a substring of the word inside custom banned password. And this is how substring matching will happen. But Azure Password Protection does not simply reject the password for any reason. Instead, Azure Password Protection will calculate a score for the chosen password, and based on the score, it will decide whether the chosen password is compliant or not. During a score calculation of Azure Password Protection, these are the rules to remember. Each banned word worth 1 point. Each remaining character worth 1 point. And in order for a password to get accepted as compliance, a total point of 5 is needed. For example, if you have a password like that, the password will be normalized to something like this, Metsis134. If we have the word Metsis in custom banned password, it will give 1 point because Metsis is banned word. And for the remaining characters, which are 3, 1 character for number 1, 1 character for 3, and 1 character for 4. So there are 3 points for the 3 remaining characters and 1 point for the banned word Metsis, which makes it 4 points. And because this is lower than 5 points, the password will be rejected. Another example, this is another example of a quite complex password. If this password goes through the normalized process, it will be changed to something like this. And even if we have test in custom banned password, because test is a simple word in custom banned password list, it will give 1 point. And for the remaining characters, which are 1988 and A at the end, it will give 5 points for them. And as a result, the password will be 6 points. And since the score of 6 is higher than 5 points, the password can be accepted. So let's go to installation process and how we can have this feature installed in our environment. And don't forget that the whole process of installation of Azure Password Protection would be, at first, we're going to install Azure Password Protection proxy on our proxy server. And in later step, as second step, we're going to install agent responsible for handling password management on domain controller. So the whole step is going to be one for installation of proxy and then installation of agent. At first, we're going to install proxy service on the server responsible for our proxy, because proxy is only going to have access to internet. I'm not going to give you the link for download Azure Password Protection because they may subject to change. So we can simply Google it out and download the binaries for installation. The installation process for installing Azure Password Protection is not really difficult. But first, we need to make sure that we have enough access to connect to Azure and also on-premise environment. So when I do who am I group, I can see that I'm part of the domain admins group and I have enough access on my Active Directory environment. After that, the installation just will run smoothly. You just install Azure AD Password Protection on your proxy server. You don't forget that this is for installation of proxy servers. We talk about agents later, but this is for installing Azure Password Protection on proxy server. Once the installation process for Azure Password Protection on our proxy server is done, we can go ahead and load the module. We load the module by typing import module, and the name of the module is Azure Password Protection. We simply load the module in order to be able to use the PowerShell cmdlets, because we're going to need them right after. Also, in services.msc, we need to make sure that the service responsible for Azure Password Protection is in running state. So if it's not in running state, make sure to run it first before moving forward. And as you can see, the service Azure Password Protection now is in running state. After that, we can simply use the PowerShell cmdlets in order to register proxy and forest. But the first one is registering the proxy. The cmdlet for that is register Azure AD Password Protection proxy. And we type the account, which is responsible for our Azure tenant. And then with the rest of the configuration, we simply register proxy server. Once you hit enter, you're going to need your password. And once you hit the password, if you have multi-factor authentication, you need to ensure that you can connect. After the connection and authentication is successful, the proxy is registered. And as you can see, the command is done. And simple as that, the installation of proxy is done. So the next step is installation of agent and domain controller. You need to know that Azure Password Protection has the same principle of password filter DLLs. If you look through the current password filter DLL of your domain controller, you're going to see that there is nothing inside it yet. So let's check it out. We go through LSA and parameters, and then we check for registry key notification packets. And inside you see all the password filter DLLs. Currently there's nothing because the agent is not installed. So installation of the agent is pretty straightforward. We just click next and this is done. You're gonna need to reboot your domain controllers. So once this is done, you need to reboot your domain controllers, and then you come back. Once it is online again, you're going to start connecting through your RDP or terminal. And let's check domain password filter DLLs again. But before that, let's check if the service for Azure Password Protection agent is in running state or not. So we go through services.msc and then we check for Azure Password Protection agent. Should be something like Azure Password Protection agent. Yeah, that's it. And that's it's responsible for gathering data from Azure Proxy. And that's in running state. If it's not in running state, make sure to run it first. We go to register to see if there was any new password filter DLLs. And when we open it up and we see, yes, there is a new password filter DLL. And that's the password filter DLL that is installed by agent. In next step, let's add some words and password in our bound list. So we go ahead through Azure Active Directory and navigate to authentication methods. And there you will see that a list of the password that has been already added as rejection list, which means that we cannot choose this password. I just added some password for that. There are two modes, audit mode and enforce mode. We're going to talk about it later, but make sure you need to know that audit mode is just logging. It doesn't enforce the policies, it just logs. Let's change some password to see what can happen. Before that, we go through event viewer and see if there are any events in the Azure Password Protection policy event, there's nothing, so we can go ahead. I copied the password in a notepad, so I'm gonna check one by one. And I reset password of a user, a test user. We start with pass1234, which is in the list, at the top of the list. Yes. And we do a reset password for a test user, and we see the password is set with no problem because we are in audit mode, as we said. If you refresh the event, that we can see there are two events in that. One says that normally the password was chosen would be blocked, but because it is in audit mode, we let the password to happen, to be set on the user. And there are two lists of banned password. There's one global list and one tenant list. We're going to talk about it later, but pass1234 is in the global list. You don't need to add it to your Azure Active Directory. It's already blocked by Microsoft. As you can indicate, as it's indicated in the event, it's in the global password list. And we do clear the event to see what can happen later. We choose another password. This time we're going to choose this one. And then we reset the password again. Again, there's no problem. But if you go through the events and refresh that, you're going to see one piece of different. This time it says that the password is in per tenant password list, which means that it was not blocked by Microsoft, but it was blocked by you because you added this word into the password list. And that's the password that we added through the list. The pass1234 was already by Microsoft, so we're just wasting our time adding it into the list. But the two, as you can see, they are added into the list by ourselves. Let's check the last one. And can be set again. And if we refresh, we're going to see that it says that the password was in tenant banned list of the tenant, and it would be blocked. But again, because we are in audit mode, nothing is blocked. So let's go ahead and enforce the policy and see what can happen. We enforce the policy by just clicking through the enforce, and we hit the save, and the policy will be enforced. Okay, so I waited enough time for the policies to get replicated and refreshed on proxy server and also the domain controller. So let's check again. We choose the password. We try to reset the password in an enforce mode. Once we type the password and then we click OK, we're going to see that the password cannot be set. And that's because the password list is in enforce mode and nobody can choose this password. If you go through the events and do a refresh and we will see that there are some difference. The very first difference is that this time Azure Password Protection says that I blocked choosing that password, because it was blocked by your list. And that's the main difference. And from now on, nobody can choose that password unless there is complete change in that password. And that's the point of Azure Password Protection. Nobody will be able to choose a password like that. So we do the clear and choose another one. Pass1234 this time. And we reset the password again. Again, it's not possible to choose that password, but let's refresh the event to see if it says it in the tenant mode or in global list. Again, it is clear that the password was blocked because of the enforcement. But this time it says that it was blocked by Microsoft. And it was not because of the list that you provided in Azure. It left only one thing to talk about, and that's how calculation of Azure Password Protection will happen and how exactly it works under the hood. So for that to understand, as we know, we have 3 passwords in our custom band password. Let's copy the one of them which is quite much stronger than the other, and I'm going to add it into a notepad to have a better view. So this is a password that is in the list of my tenant, which means, as we said, nobody can choose this password. But why nobody can choose this password, and why? If we even add other characters to this password, it's not gonna work. So let's test this password and see if we can change it or not. Again, I'm going to use my user and I try to change the password. So as we know, it's not going to work because it is in the password list of the tenant. But let's try to add more characters to this password to see if that get accepted by Azure or not. Which means that this is the default password. If I add another character to this one, let's see what happens. I'm pretty sure it's not going to work. Yeah, not gonna work. So again, let's add one more character, which makes it a bit stronger. No results. Let's go a bit further and add one @ sign to the entire password. Is that going to work? Not again. And let's go for the last time. Add another thing. Add another character. And this time it should work. Yes. So why this can work and why not the others? Let's analyze the password that we use. This is the password, the basic word exactly that we have in the custom list. This one. So, which means that if someone chooses this as a password, it's going to be considered a single word which is completely blocked and nobody can use it. Nobody can have this in the password, not any variation of this. Why? Let's go through the cycle of evaluation and see what happens. The first thing is that we said normalization, which means that the password that we can see right now, which is super strong, it's going to be converted. So this is going to be the pure password, pure word that we're going to have after normalization. The difference between this one and this one is nothing. They're exactly the same. And this word is exactly, as we said, is in the custom band password. So nobody can have this in their password. If we want to give a point to each one of them, as we said during the cycle of evaluation, for each word that is found during the change password process, it's going to give 1 point, which means that because this password is this word is already inside the custom band password, it's going to give 1 point for that. So when we try to change the password to this one, it gives 1 point, and 1 point is not enough to get accepted by a validated password. But the second is, what is the difference between these password and these one? There's only one unique characters. So which means that if you want to give a point to this, it's going to be 1 plus 1. Because 1 for this entire word and 1 for this. So it's going to be 2. The same thing applies to this one, because this one, there's only one more different, and the word is going to be like this. So it's not again accepted. And again, the difference between this one and this one is this @ symbol, which means that if we give a point to this, it's going to be 4. And the last one, it get accepted because the point is 5. And as we said during the previous slide, if a password is given 5 points or more than 5 points, it is considered a validated password, and we can have that password as our new password. So that's why we cannot have all these passwords to a new password, although they are super strong, they can be strong, but this one we can, because there is form or character that is completely different from this one. If you remove this part is the difference between this password and this password, and believe me or not, if this is going to be completely different password, and this is much stronger than the first one. So that's why evaluation accept this password as a validated password. As we saw, the installation of Azure Password Protection is not quite complex, and it's quite easy to implement. But there are some key points that we should keep in mind. The first point is, we talked about list, but how many lists do we have? As we saw, there are 2 lists. The first thing is global list, and the second thing is tenant list. Global list is a list that is always provided by Microsoft, and it is updated by Microsoft, and we cannot interfere with that list. It is handled by Microsoft. But tenant list is a list in which you can add your own custom passwords, the one that we did in implementation process. Also, if you want to know if your list is updated or not, you can simply check sysvol folder. Because as we said, inside the sysvol, we have the configuration and all the policies related to Azure Password Protection. So if you restart the domain controllers and see that the modified timestamp of the configuration file of this Azure Password Protection is not so updated, which means that you have some kind of problems connecting to Azure. By that I mean, if you want to see if the new list is downloaded or not, you can simply check the data modified of password policies. If this is recent, which means that the passwords are up to date, otherwise, no. Also, you need to know that Azure Password Protection is not a replacement to fine-grained password policies or password policies. Azure Password Protection is just an enhancement. It can't be replaced by fine-grained password policies or password policies. And for the last thing to know is that how DC will find a proxy. The first thing is through the agent, and also we need to know that the information is also stored in Active Directory. If you look inside the attribute of your proxy server, as we can see, there is a service connection point to proxy service, which can easily let domain controllers to find the proxy. And that's how domain controllers will find the proxy server. That's it for the end of the video. I hope you enjoyed this video, and I hope it was easy for you to follow and understand, and I hope I see this feature installed in your environment. Until next time.